Hi everyone, my name is Georgia Greenblum, and today I will be speaking with you about my research on anemia and socioeconomic status among older adults in the study on global aging and adult health. I want to first take a moment to recognize the World Health Organization for its funding and contribution to this study. This would not have been possible without their support. Additionally, I would like to acknowledge my mentors, Dr. Snodgrass and Alicia DeLuise, for their support. And lastly, the Global Health Biomarker Lab. My research was conducted in the biomarker lab on campus. This lab focuses on the development and application of minimally invasive techniques, such as dried blood spots, for assessing health and physiology in population-based research. The research I have conducted will be centered around anemia. Many of us may be familiar with the term, whether it be through research, experience, or even personal diagnosis. And in fact, over 33% of the world's population is affected by anemia. Anemia is a condition in which there is a low concentration of hemoglobin, a protein found in red blood cells that transports oxygen throughout the body. Anemia can be found or can be caused by nutritional deficiencies, environmental factors, medications, malaria, inflammation, chronic diseases, the list goes on. Symptoms of anemia may include fatigue, weakness, irregular heartbeats, and more. This can all lead to increased mortality and morbidity, poor birth outcomes, and impaired cognitive and behavioral development in children. And while anemia is a serious global health public concern for many groups, research and interventions have typically focused on young children and pregnant women because of the impact and risks of anemia from growth and development, as well as reproduction. However, older adult populations are increasing globally. It's reported that by 2050, 80% of older people, those age 60 and above, will live in low middle income countries. And while anemia affects roughly 33% of the world's population, low middle income countries account for roughly 90% of anemia cases. So this condition can be caused by congenital conditions or developed later in life. Not only can anemia be induced by other diseases, but it can also put individuals at risk for the development of many different medical conditions, such as kidney disease. Now, where does socioeconomic status come into this? SES, or socioeconomic status, is generally defined as the composite measure of a person's wealth, education attainment, and employment status. One's ability to access care is often strongly shaped by their SES. Previous studies of anemia demonstrate higher levels of wealth and education are generally associated with a lower prevalence of anemia in LMICs, or low middle income countries. These factors can cause anemia by influencing access to diverse food sources, health services, clean water, and sanitation. A major gap in research on anemia and SES is the lack of major research among older adults. Ultimately, SES is often closely tied to healthy aging. And while low SES also contributes to a heavier disease burden, the present study examines the relationship between SES and anemia by focusing on the individual components of wealth and education. So the purpose of the present study is to use data collected from 2007 to 2010 from the World Health Organization's study on global aging and adult health, known as SAGE. And our goal was to describe the anemia rates for roughly 15,000 individuals 50 years and older from 3 middle-income countries, South Africa, China, and Mexico, as well as to investigate associations among anemia, age, and components of SES in those 3 countries. The hypotheses were 1, that lower individual wealth would be associated with greater anemia, and 2, lower education levels would be associated with greater anemia. So, how did we get this all done? On the study on global aging and adult health, SAGE is a comprehensive longitudinal study of health and well-being on older adults and the aging process in 6 middle-income countries. So that is China, Ghana, India, Mexico, the Russian Federation, and South Africa. For the SAGE study, participants were randomly selected from population census data to create nationally represented samples, and comparative samples of younger adults aged 19 to 49 were also obtained from each country. The present paper concentrates only on 3 SAGE countries from which biomarker data was available. That's Mexico, South Africa, and China. Now, these participants were a subset of older adult individuals participating in biomarker portions of the SAGE study in these 3 countries. Roughly, again, 15,000 of them aged 50 to 99 years old. This is some of the information gained just their age, education, and health. In relation to that biomarker data, surveys were also conducted. So both in-person interviews as well as computer-assisted programming in China, South Africa, and Mexico were done. And again, data collected from 2007 to 2010. These surveys were asking questions regarding gender, age, marital status, education, self-rated health. Further questions regarding aspects of socioeconomic status were also given, such as income, assets, and other housing characteristics. In order to concentrate among the hemoglobin, the biomarker collection and lab methods used to measure hemoglobin differed by country, as the specific analysis was determined by in-country lab teams in collaboration with the SAGE leadership. So for China and South Africa, dried blood samples were collected by using finger prick capillary blood and then was spotted onto standard filter paper. This is in contrast to Mexico, which also used dried blood spots, but used venous collection blood onto standard filter paper. For all countries, the biomarkers were analyzed using high-performance liquid chromatography. Anemia cutoffs, as seen on this page, were classified based on hemoglobin levels determined by gender as generated in a 2011 study by the WHO. This table shows how individuals' anemia levels differ by age and gender at sea level. Statistical analyses were performed in R. All statistical assumptions were checked before analysis. Clustering, due to this complex sampling design, was controlled by including the community level sampling units as a random intercept. So in China, the community level sampling units were villages and neighborhoods. In Mexico, communities were defined by the National Institute of Statistics basic geostatistical areas. And in South Africa, they were defined by the Human Sciences Research Council's population enumeration areas. 6 mixed effect binomial logistic regressions were used to predict categories of anemia from age, gender, marital status, self-reported health, wealth, and education for both men and women in each of these countries. So what were the results? What did we find? The rates of anemia were 28, 24, and 91% in China, Mexico, and South Africa, respectively. This table on the left demonstrates how the rate of anemia was higher and the average level of hemoglobin was lower for women in all 3 countries. Specifically, after analysis, low wealth was associated with the presence of anemia for women in Mexico and for men in China. Looking at education, higher education was associated with the presence of anemia for women in China when controlling for wealth, age, health, marriage, and community level clustering. So this means for every 1 year of education, there was a 3% increase in the risk of anemia. Lastly, by looking at age, older age was closely associated with the presence of anemia. There was an association between age and anemia in men and women from China and Mexico. So women in China and Mexico both had a 2% increase in the risk of anemia for every year people were older after 50 years of age. Men in China had a 3% increase in anemia risk for every age after 50 years. And men in Mexico had a 6% increase for every age after 50 years as well. In addressing random effects and covariates, much of the variance in presence of anemia was accounted for by community level clustering. So China had the most community level clustering of anemia, South Africa following second, and Mexico following just after that. Now, what does this all mean? What do these numbers and these results all give us? Well, in short, the results show that the rates of anemia in older adults in China, Mexico, and South Africa are a moderate to high public health significance. The public health significance of anemia in South Africa is extremely high. The current study also shows how anemia prevalence is higher with increasing age. The public health concern of anemia identified in this cross-national study demonstrates the necessity of health policy related to anemia for older adult populations. Anemia and SES components. In our hypothesis, we found that SES would be related to anemia was only supported in certain groups. For example, low wealth predict the presence of anemia in men in China and women in Mexico, but not in South Africa, whereas high education levels were associated with the presence of anemia only for women in China. Although it was hypothesized that low levels of education would be associated with high rates of anemia, the opposite was found for women in China. And this is likely because of the overlap between community level clustering, wealth, and years of education. None of the variables analyzed were associated with the high anemia rates seen in South Africa, warranting the further study of anemia in this specific population. The present results are somewhat different from previous studies that show that low wealth is consistently associated with anemia. However, previous studies did not focus on older adults in low middle income countries. Now, we found that education was positively associated with the prevalence of anemia in women in China, which is likely due to, again, the community level clustering. Limitations of this study. The hemoglobin rates for anemia were not adjusted for altitude. This could lead to an underestimate of anemia rates. Additionally, the subset of participants for which biomarker values were available came from a convenience sample. Biomarker analyses were also conducted in separate labs with different lab techniques in each country. This was done in order to expand the laboratory capability of participating countries. However, therefore, the data may not be accurately comparable across countries. Furthermore, one possible reason for the increased anemia rate in South Africa is the prevalence of the human immunodeficiency virus, or HIV. However, we did not have data on participants for HIV status. In summary, this study highlights the enormous burden of anemia in older adults in these 3 middle-income countries. Global demographic trends are leading to an increased older adult population in low middle-income countries, which means the burden of anemia in older adults in these countries will only increase. Anemia prevention efforts have generally concentrated on only women and children. However, with demographic trends, more attention should be paid to the burden of and prevention of anemia in older adults. Thank you for your time and for listening.